In this video, you'll be able to understand the conditions with respect to addition and subtraction of currents in a parallel circuit. So I'm Mohan BS, working as assistant professor in Department of EEE, SJBIT. So what are the characteristics of a parallel circuit? As we are aware, in a parallel circuit, the voltage remains same along with polarity, in the sense at the top of the circuit if we have, or at the branch end of the end we have positive, a parallel branch will also have the same polarity. And we also know here the current would get divided, thus we can add or subtract depending upon the orientation of the current or how does it flow. So let's see one by one. Now as we have seen in the video with respect to voltage, if not, let me explain here in brief. So current 8 amp is moving up in upward direction. So as we are aware, the current and voltages in a DC circuits are vector quantity, in the sense which has both magnitude and direction. Thus if I change the orientation of the current direction, the magnitude becomes in opposite, that is -8. Or if you change the magnitude from +8 to -8, the orientation of the current would be in opposite direction. So let us take an example to understand when do we add and when do we subtract. So here we have 5 amps and 6 amps which are connected in parallel. So let's see what's its resultant. Now as both currents are traveling in same direction or towards terminal A, I repeat, both 5 amp and 6 amp are traveling towards one terminal, that is terminal A. Thus we have to add them, and adding them we have 11 amperes. Now from the above example we have seen that we can also rewrite this as -11 by changing the resultant orientation downwards. As we've changed direction, the magnitude also changes to -11 amperes. Now, so I want you to observe the current 6 amps orientation now has been changed to downwards. So as the orientations are in opposite direction, that is 5 amp is going in upward direction and 6 amp is going in downwards direction. As the directions are opposite, thus we need to subtract. So subtraction, there are two ways, that is either 6 minus 5 or 5 minus 6. Now let us always subtract from the higher polarity. So as we subtract from the higher polarity that is 6 minus 5, we have the answer as 1 ampere. Okay, now why did I subtract from 6 minus 1? Now since I have subtracted from 6 minus 1 here, the orientation is also as per the 6 amps. Now let us say I subtract the other way. Let us say if I subtract 5 minus 6. So if I subtract it as 5 minus 6, my answer would be -1. And the orientation is as same as in 5 amp. So if you've seen the video with respect to voltage, now it's clearly explained there. The same principle is applied here for subtraction also. So I repeat, if the current directions are in opposite direction, you must subtract. So from which you are subtracting, retain the same polarity in the resultant. So first example, 1 ampere. How I got 1? Since the subtraction is 6 minus 5. Since I'm subtracting from 6, I've retained the polarity in the same direction, that is downwards. If I subtract from 5, the answer is 5 minus 6, that is minus 1 ampere. And since I'm subtracting from 5, I've retained the same polarity, that is going upwards. So or once I've got the result as 1 ampere going downwards, if I change the orientation, I'll get that as -1 amperes. Now, so let's change the orientation of 5 amps downwards. Now since the both directions are going in downwards direction, we have to add and simply write that as 11 amperes going downwards or -11 amperes going in upward direction. So I want you to pause the video and write down the resultant for these answers. So I hope you have paused and written the answers. Let us verify now. Now, so here what we have done is we have given the orientation also as resultant, and based on that one has to solve. Now for the first one, 1 and 6 both are traveling in upward directions, we must add. And after addition, we get that as 7 amperes, and the orientation also is in upward direction. Okay. Now next one. Now as we are aware that 5 and 6 are traveling in upward direction, we must subtract. But the resultant is going in downwards direction, thus we must subtract from 6 amperes. So 6 minus 5, we get 1 ampere. Okay, and for the next one, both are traveling in upward direction. As the resultant is in upward direction, subtract from 8. So 8 minus 5, you get 3 amperes. So as you change the orientation of the currents, the magnitude also changes. So 7 amp going up, minus 7 amp going down, 1 amp going down, minus 1 ampere going up, 3 amp going up, minus 3 amperes going downwards direction. So I hope you have understood how do we add and subtract current. Thank you for watching the video. Please do subscribe to the channel to enhance your knowledge further.